Okay, so hi everyone. So my name is Irvi. Today I will be presenting about tracing simplified and introduction to microservices observability with Dapr. So next, this is more about me. Currently, I'm a master's student in data science at the University of Edinburgh. I'm also a CNCF ambassador, and my past experience mostly related to software engineering. This is my previous employer. There's like Motional, Spotify, and then Lookup. And this is today's agenda. First, I want to have some kind of like introductions to observability. Next, we will try to kind of like understand tracing. And the third one will be some kind of like reminder or overview about Dapr. Next, we will try to kind of like implement tracing with Dapr. For the last thing will be Q&A sessions and closing remarks. And this is more about like introductions to observability. So we often heard about observability in distributed system and microservices, right? So why we often heard about these things? What's the importance for like observability to come into the picture? So observability is actually the key in managing complex microservices architecture because it can provide insight into how different parts of the system are performing and interacting. And effective observability actually helps in identifying and resolving issues quickly, ensuring the system reliability and performance. And there is like three different components for observability. The first one is metrics. Metrics is more like numerical data that can provide insights into performance of the system. Example includes response time, error rates, and resource utilizations. Second one is logs. Logs are records of events that occurs within applications, and this usually come into the picture when we are trying to debug and then try to kind of like understand the system behavior over time. Next, we have tracing. Tracing actually tracks the journey of a request across various microservices, and it helps in identifying bottlenecks and understanding the flow of requests through the system. So, what's the benefit of observability? It will bring confidence, especially in a complex cloud environment. It can also improve organizational alignment. For example, uh, we have a request to try to kind of like improve the system, or we get like a feedback from the users that our system is getting slower, right? To be able to narrow down what kind of like things that actually uh, become a bottleneck, we need to gather more data. And by using a tracing, we can actually, or observability in general, we can narrow down the components that causing like the slow responses, and how we can actually get like a faster feedback loop when try to kind of like improve our system performance. And because it's easier for us to narrow down problems when an issue is actually happening, so it will also help us in the terms of like preventing unnecessary downtime, or making like a downtime is kind of like longer, because we don't know how to kind of like pinpoint the problems that actually happening across our system. Next, we want to kind of like understand uh, what's actually tracing is. So traces actually shows the request path. They tracks where the request actually goes and which parts of the system it interacts with. Traces actually resemble logs, but they are kind of like a special kind of logs which records each steps of a request journey. And traces reveals work details. They show how much work is done at each step of the system. And traces actually maintain the order. They are using a special rules called happens before semantics to keep the events in correct sequence, showing which actions lead to the others. In short, traces are like storybooks that narrate the entire journey of a request through a different parts of the system from start to finish and in the correct order. So this is like example on how a sample request actually works, right? Imagine that we have 4 different components which are being represented as alphabets here, A, B, C, and D, and then we have one external component which is Redis that being called by service B. We can see that the request actually started from A, and it will actually chaining down into external dependencies, which is Redis, and then other components like C, B, and D. Then next we will end it up with like various informations for each of the step invocations, as well as the total like journey between like the first incoming request to the result. And the first component of the distributed systems that being touched here during the life cycle of a request actually represented as a directed acyclic graph. And this is how trace actually looks like. A trace is actually represented as spans. We can see here span A is actually root span, and span B is a child of span A. So whenever a request is actually like coming, then we will generate a new span here, and we can gather like informations from each of the span and propagate it back to like the root span. Thus we will get like the whole trace. So what is the challenges when we try to kind of like do tracing? First one is complexity, because there is a distributed nature of microservices that can make tracing actually challenging, as a single transactions may span multiple services. And then second one is consistency. Ensuring consistent and accurate data collections across different services is crucial but difficult, because it will add more complexities when we try to collect all of the information that we need. Next, we will have like overhead, because implementing tracing can actually add overhead to the system, which needs to be managed effectively to avoid bottleneck on the tracing system itself. So we have like Dapr into the picture right now, right? So Dapr actually allows us to use any code or frameworks to our liking, and then perform HTTP API or gRPC API to access service invocations, state management, messaging broker, actual secrets, configurations, and so on by using the Dapr runtime. And then we can deploy this on top of any cloud or edge infrastructure like Azure, AWS, Google Cloud, Alibaba, Kubernetes, virtual, or even physical machine. Such is actually really flexible for us to do things to our liking, right? And then how actually distributed tracing works in Dapr. Imagine that we have like 2 different service components here called A and B. And for each services, it will be connected into its own sidecar container, which in turns are running Dapr, right? So when we are reading like a service invocations or trying to do some kind of like events, then Dapr will release this or will emit this tracing into like any monitoring tools that we want to use. For example, like Zipkin, Jaker, New Relic, or any kind of like vendors like Datadog and so on. And yeah, for the monitoring tools, we can visualize how the chain of call from like a single request is actually happening or interacting with each others. We also can get informations or like can infer the informations on when we actually having some kind of like external dependencies. In this form, it's actually a PubSub component by using a Kafka. So we already know on how distributed tracing in Dapr actually works, right? It's actually using the Dapr runtime on each of the sidecar container attached to each of the services. How it is actually being generated by Dapr? If you are using Dapr, you will get these features by default, meaning that Dapr will generate the trace for you, and it will be in the form of W3C tracing specifications, which is actually included as a part of OpenTelemetry or OTEL. And Dapr will be the one that actually generate and propagate the context header for the applications. Or if let's say you are sending a request from a non-Dapr environment, then it will propagate any kind of like custom user provided context header and put it into like any monitoring tools of our liking, which is quite flexible because you don't need to migrate all of your services into like a Dapr environment. But if let's say you want to kind of like implement or like incrementally changing your system by creating, for example, like still using the legacy system and creating your own like user provided context headers for the spans, and then calling like lattice services which actually using Dapr, you can still pass these informations to like your lattice system. Next, what kind of like scenarios that being supported by Dapr? So Dapr, as we already know, right? Dapr will generate the trace context, and there might or might not be a need for you to propagate the trace context to another services. If let's say you want to use the same spans for multiple services, then you will need to kind of like propagate the context header by your own. But if let's say you decide just kind of like let each of the service communications to have its own span, then there is no need for you to kind of like propagate the context header by yourself. And if let's say you decide to generate the trace context from outside of Dapr environment and then doing some kind of like system invocations to your Dapr runtime, then you can actually generate this trace context by using a standard open telemetry SDK, any kind of like vendor SDK or W3C trace context that you can create by your own. And yeah, so how actually tracing context looks like. There is two different things that actually exist within like tracing context in order to be able to support interoperability and vendor-specific extensibility. The first one is transparency. Transparency actually describes the positions of the incoming request in its trace graph in a portable fixed-length format. So every tracing tool must properly set transparency, even when it only relies on vendor-specific information in trace state. Trace state extends transparent with vendor-specific data represented by a set of name and value pairs. This trace state is actually optional, right? This is more like adding any kind of like additional information that you want to have on your trace. Next, how transparency actually looks like. So there is like 4 different informations that you will have inside of like transparency. The first one is versions, trace ID, parent ID, and trace flags. And it will be in the forms of like BAS16 format. You can see that each of the information that we will have here is separated by a dash. And for the trace flags, it is kind of like sampled by the trace generation itself. And next, this is how trace state actually looks like. The trace state will contain any kind of like opaque values in any forms of like keys and values pair. So let's say we want to kind of like add two different keys and values pair here, then it will actually being like presented as like opaque values without any kind of like any need to decode it into another form. So we already knows that if let's say we want to for some kind of like custom usage, right? We want to kind of like pass through a same span over several different services. We will need to pass the context header by ourselves. First one, we will need, of course, a transparent slide because it is needed for all of different surfaces to, sorry, for all of different faces to have like transparent headers. And if we want to, we also can get the trace state headers. So that's only two things that we need. And the header name is actually just the same as the W3C schema that we already discussed before. And for the gRPC inside of like Dapr, it will have different headers. And the header name is actually gRPC trace bin header. So we will have here a quick start for self-hosted mode. I'm sorry, but I can't do any kind of like demos because somehow there is some kind of like problems with my laptop. So this is actually being taken from a quick start from Dapr. And code is actually written in Python, and we don't actually need to do anything for the sake of like emitting the traces by ourselves. What we need, of course, is having like a Dapr installed on our environment, and we will need to kind of like run Dapr init, which will generate YAML configuration file. If let's say we run it in the Unix-like environment, it will be within our home /dapr/config.yaml. And if we run it for Windows, then we will have it inside of like our user profile /dapr/config.yaml. And this is like the content of the configurations, and it will by default using a zipkin, and we will need to kind of like provide the endpoint address, and this is like the default configurations that we will have. And next we will need to kind of like launch the OpenZipkin Docker container, because it is where we will actually push all of our traces, and we will be able to kind of like get visualizations for our traces here. And if let's say the applications is being launched by Dapr run, and this Dapr run will by default reference the config file within like our environment. Of course, it's if it's kind of like Unix like, then it will be on our home, and if it's kind of like Windows, then it will be within our user profile. And if let's say we decide to kind of like override the configurations, we only need to kind of like pass test config param, and we will need to kind of like clone the Quickstart repository. And after that, we need to run the code. There is some kind of like Python code and then Node.js code as well. And once the app is actually running, we need to make a service invocations using Dapr invoke with the provided request content within the repository. And next, if let's say we already do the invocations, then we can actually get the traces from like our visualization tools, which is using the Zipkin, OpenZipkin, right? There is two different mechanisms in order to kind of like access the OpenZipkin. The first one is of course using the Zipkin UI, which can be accessed within the local host with the port of 94011, right? And then we can also calling the Zipkin by using Zipkin API using a curl, and we need to kind of like specify the span name, and then we'll output it into the output JSON, and we can take a look into what kind of information that we will have within this result, right? First one is of course like the trace ID, a kind, name, and then we will get some kind of like information, right? The service name, of course, and API endpoint, which being accessed when we are using Dapr info, the status code, protocol, and the subscriptions, and so on. Yeah, so basically that's it. And if let's say we decide to kind of like use Kubernetes on like a cloud infrastructure, then we should make sure that the Kubernetes cluster already have like Dapr installed, and we are ensuring that each of like our services have a Dapr sidecar container to kind of like emit the traces, and we can also configure on what kind of like tools that we want to have as the monitoring tools in general. Okay, so basically that's it. And there's like a few Dapr resources that you can access. First one is of course documentations within Dapr.io. And we also have like a channel called Dapr in YouTube. And this is like the tutorial that we discussed in the sessions, which is like Dapr Quickstarts. And we also have like a Discord for Dapr community. And last but not least is a X account for Dapr, which is Dapr Dev. Okay, if there is any kind of like questions, feel free to like ask it in the chat. Yeah, basically that's it. Thank you for your time.